Example 5, once again, one more example for you to see how you can use the square root, complete the square methods. So we want to solve for x. This time I have 2x squared minus 7x plus 3 equals 0. This time things are all over. Your equation for sure is not in ordinary form. So you need to bring that into the ordinary form. Now what happens here? So I have the x squared term, I have the x term and the non-x term. I need to bring that last term to the other side. So subtracting 3 from both sides, and that gives me 2x squared minus 7x equals negative 3. However, the question here is, am I in my ordinary form, making it ready to solve using the complete the square methods? Not quite there yet. Now, if you check back with the ordinary form, my current equation right now is not quite in ordinary form for the reason being, the leading coefficient here is not a 1. The leading coefficient I have here is a 2. So, what can I do with that? I just, at this point, need to divide both sides through by a positive 2. I need to divide that leading coefficient away, so I divide that positive 2 away from both sides. So now it takes me down to x squared. The first term after the 2 cancels, the 2's cancel. I have x squared. And now minus 7 over 2x. And once again, please, at this point, start accepting the fact that we're going to start using a lot of fractions here in college algebra. So I have x squared minus 7 over 2x equals negative 3 over 2. So now your equation is in ordinary form. Your x squared term is having leading coefficient 1. Your x term having coefficients, lead coefficient, negative 7 over 2. Your c term is a negative 3 over 2. So at this point, I'm ready to use my completing the square methods. The magic number in this case, once again, always the formula is b over 2. So that would give me minus 7 over 2 divided by 2. And then once again, if you're not sure with your fraction skill, make sure you go back and review. But my answer is here, negative 7 over 2 is going to be negative 7 over 4. That is actually my magic number. And so, once again, once you have found a magic number, what you need to do on the right-hand side, which right for now contain negative 3 over 2, I'm going to add the square of the magic number. So, to the right-hand side. So I just added the square of the magic number to the right-hand side of the equation. The left-hand side, nothing is easier than producing for yourself a pair of parentheses with a square, and now you put the x here without the square, simply just the x. And now your magic number, you put it as the way it is, negative 7 over 4. So watch out with the signs for the magic number. You put the magic number inside of the pair of parentheses. And all that here you square. So your equation, after clearing it up, and once again, if you're shaky with your fraction skill, make sure you check out my other videos for how to operate with fractions. But here, after you finalize all the work, it's going to be minus 3 over 2 plus 49 over 16. And so, adding the two fractions on the right-hand side, that would give me a 16 overall. Minus 8. So, positive 40. Minus 3 over 2 plus 49 over 16, that gives me 25 over 16. So now at this point, once again, in my current equation, I have one perfect square equals to a number on the right-hand side. So what I can do, once again, I can just now use the square root property. Here I have x minus 7 over 4 without a square equals to the square root of a whole fraction. 25 over 16 plus and minus. Now once again, check out my other videos on how to take square root of a fraction. But at this point, your equation really turns out to be x minus 7 over 4 equals plus and minus 5 over 4. And so, Meaning, on one hand, x minus 7 over 4 equals positive 5 over 4. And on the other hand, x minus 7 over 4 equals negative 5 over 4. So now once again, I have just produced for myself two sub-equations to solve for. So on the first sub-equation, I'm adding 7 over 4 to both sides, and that gives me x equals now 7 over 4 plus 5 over 4. That gives me, once again, check your fraction scale. Allow me to move a little quickly here, but 7 over 4 plus 5 over 4, that gives me 3. Because all together that would make 12 over 4. Now on the other hand side, I need to add 7 over 4 to both sides once again, and check with your fraction scale if you need to, but allow me to move fast here. So x would equals to, now 7 minus 5, so it's going to be 1/2. So that's my other solution for the equation. Okay. One more example for today, as we would call that example number 6. Try to solve for x. Once again, one more equation where you can see the leading coefficient here is other than 1. 4x squared minus 4x minus 1 equals 0. So once again, before you attempt completing the square, you need to ask yourself, is my equation here in the ordinary form making it ready for me to complete the square? Not yet. So what I need to do, simply add 1 to both sides, and that gives me 4x squared minus 4x equals 1. And here, I'm not even at the ordinary form yet because my leading coefficient, my x squared term, has coefficient 4, which is other than 1. I do not want that. I need to bring my equation into the ordinary form. So the only way around with this is to divide 4 throughout both sides, throughout all the terms on the two sides. So what I can do here is the 4 cancel with the first term, that gets me simply just x, and then the second term becomes minus x equals 1/4. Now I am ready to solve for to complete the square. Here I'm ready to complete the square. I have this square term, the x squared term with leading coefficient 1. The x term with leading coefficients -1. And my c constant on the other hand side is a 1/4. And so at this point, my magic number, once again, my magic number always b over 2. And in this case, it gives me -1 over 2. And that's my sign, -1/2. That's the sign of my magic number, -1/2. And so, once again, as part of the complete the square methods, your equation here, the right-hand side, which for now contains 1/4, you're going to add the square of your magic number to the right-hand side. And on the left-hand side, just the left-hand side, nothing is easier than producing for yourself a pair of parentheses with a square, and the x, simply just the x inside of the parentheses. Nothing is easier than doing that. And then you're going to put the magic number, the whole thing, just the whole, whatever it appears to be, the magic number, into the parentheses. And now you have x minus 1/2 all squared equals 1/4 plus -1/2 all squared. And keep in mind, if you're not sure what fraction, once again, check with your fraction scale. But -1/2 all squared equals to 1/4. So you have 1/4 plus 1/4. X minus 1/2 all squared. And so cleaning up my equation, I have here 1/4 plus 1/4 is the same as 1/2. And my equation is x minus 1/2 all squared equals 1/2. And so, at this point, I am now ready to use the square root property. Square root property is saying that I can just simply remove the square roots on the left-hand side, and then on the right-hand side, I'm doing square root of 1/2 with a plus and minus. And at this point, keep in mind, I have a square root, an irreducible square root in the denominator, so I need to rationalize my denominator once again. So if you're not sure how to rationalize the denominator, make sure you check out my other videos, show you how to rationalize the denominator. But here what I have is plus and minus square root of 1/2. that gets me plus and minus square root 2 over 2. And here my equation turns out to be x minus 1/2 equals plus and minus 2 square root 2. And at this point, once again, I have on one hand x minus 1/2 equals positive square root 2 over 2. On the other hand, my equation turned out to be x minus 1/2 equals negative square root 2 over 2. So I have two sub-equations to handle. And so my first sub-equation, all I have to do is just simply add 1/2 to both sides. And that gives me x equals 1/2 plus square root 2 over 2. And here is my first answer. In my second equation, once again, I need to add 1/2 to both sides of the equation, and that gives me x equals 1/2 minus square root 2 over 2. And here's my other equation, my other solution.